Hey everyone, today I'm working on an iPhone 6s that was sent here for a backlight failure. It wasn't immediately clear if it was after a screen replacement, if it just happened out of the blue. That's typical for backlights that just short for no reason, so I'm going to show you what it is that I am up against. As you can see, this board has already had somebody attempting to repair the backlight. If we get right down in there and we look at FL4211, look at that, FL4211 has a piece of wire across it. So what are we going to do with that piece of wire, folks? We're going to exterminate it. Piece of wire out of there. We can test the filter with an ohms meter. You can check in resistance mode. You can check in diode mode. Either one should give you dang near zero. My multimeter is not working on screen right now, so you will just have to take my word for it. If we check across this filter that was bridged, FL4211, I get 1 ohm, so we know that that filter's good. What that means to me that if the backlight filter's good, there's something that's failed in the backlight circuit, which is usually a short to ground on the iPhone 6s. And also the iPhone 6 does it very commonly too. So if I put one probe on ground, and I put another probe on either side of this filter, since we know the filter's good, you can check on either side. I'm getting 1.5 ohms to ground. Now, what that tells me is that the backlight output on this phone has a 1.5, it has a short to ground. Now, I'm going to open up Easy Draw here and show you what it is that I've determined. This is a really, really simple problem. And also, I would like to show you Easy Draw. I've really been liking this program. It has one feature that has been saving me tons and tons and tons of time. Now, one thing that I have not been able to find yet is long screw damage net names. So if somebody can tell me a way to get net names on this thing with long screw damage traces, that would be great. But it has one feature here that I have really, really, really been liking. Look what happens if we go up here and we click on double open graph. We're working on an iPhone 6s. So let's pick double open iPhone. Let's go ahead and pick the 6s bitmap, okay? And let's wait for this thing to load. And we zoom in. Let's just go ahead and pick FL4211 over here, okay? And watch what happens when I click on FL4211. Oh, look! The schematic on this side changed too. So to make this a little easier, you can zoom in real far over here, and then just come over here and pick a component. Let's pick FL4212. Oh, and look what happens. The schematic automatically took us to FL4212. Now, one other thing that you can do with this software that I have not seen that you can do a ZXW tool, you can have the two of them open, and you can even open up a third one, fourth one. I don't know how many it'll work on. I know you can use it on multiple computers. So back to this backlight problem. If we zoom in here and we look at FL4211, this is the one where we're detecting a short, and we follow that all the way back to backlight anode con. Wait, no, we want anode on this side. And it takes us here to the backlight circuit. Yeah. So what I've determined, we have checked out here at PPLC and backlight anode. That's where we checked out here at the filter. And we determined that there is a short to ground there. In order for there to be a short to ground there, we have to have a short on one of these capacitors. So we have determined this iPhone 6s has a short to ground on backlight output. So let's start heating this up. Now this is a prior attempt. Somebody has already put a wire across the backlight filter even though backlight output was shorted to ground. So if you're working on an iPhone 6s or iPhone 6 or any iPhone and the filter looks good, you can check it with a multimeter in ohms mode or diode mode. In ohms mode, you should read, 1 ohm and less, 2 ohms and less even. If you're measuring in diode mode, you should get close to a 0 volt drop to ground. Okay, this is going to fall off here any minute. Let's go ahead and ramp it up. There we go. So let's get this iPhone 6s under the microscope so you can see what this looks like. This is cool. Look, we don't hardly have any underfill. I'm not going to have to replace the driver. Guess who's not going to have to replace the driver? Right? Am I going to be able to cheat out on this one and do a cheap repair? And some people tell me, I can't believe you didn't replace the driver. I'll admit, it did come back for a warranty repair. So what we're going to be doing here is we're going to remove C4023 first, because that's the biggest, baddest cap there, and that is typically the one that causes me all this grief. You can also see that this one has balls and stuff oozing out from around the diodes. That's a really bad sign. So let's go ahead and get some flux on this cap here. I am going to go ahead, to be nice and proper, we're going to put a piece of metal over the CPU here that is like 64th inch steel or something. That's really heavy duty stuff. And let's see, I'm going to grab a hold of that cap with tweezers. Let's warm it up a little bit with hot air. Got to get new tips on these tweezers already. My tweezers were screwed up when I got them. They did not align properly, and by the time I got around to dealing with it, it was too late to send them back, and I wound up fixing them myself. But in the midst of all that, I filed and really messed up these tips. Alright, so we're going to get a hold of this cap. Little hot air, little tweeze. A lot of times this cap is welded to the board. That wasn't too bad. Alright, so we got the cap lifted out of there. While that is still fairly warm, let's see. Let's just go ahead and swipe the diodes out of here too. And you'll notice I'm not trying to be too damn careful. Alright, that feels like it might be welded to the pad. I think that's welded. Yeah, that sucker was welded down good. Alright, let's see if we can clean all this up. And then we're going to evaluate our damage here. See how we're actually going to be fixing this one. Da, da, da. Alright, so we've got plenty of solder on those things. Now let's look and see what our missing pad here is. Here we are on screen capture. And as you will see on this diode here, D4021, we have lost a pad. And that pad goes right over under the corner of this IC. Under, this is A3 and A4. And that is one of our critical diodes here. Okay, now how does that trace run underneath? Are we still going to have continuity to the coil? Okay, so what I'm trying to do now, I'm trying to check and see if this coil is good. And I should get 0 ohms across that coil if I check on this side of it and also to this capacitor. So what I'm going to try to do, I'm going to try to get one probe on this side of the coil and then the other probe on VCC main here. And I'm getting 7.9 million ohms. Let's test this other coil. This is going to test the bottom coil. We're going to put one probe on this pad for the diode, and I'm going to put my other probe on VCC main. So this one is what I consider to be an absolute complete total meltdown. I've checked for continuity now between this side of this coil and VCC main, and I've also checked for continuity from this side of this coil to VCC main. Both of these coils are open. Both of these coils are blown. The pad for D4021, that is completely gone. That is history. So this is going to be an absolute complete total rebuild, and I'm going to start it right now. Let's kick the multimeter aside because we should not be using that no more. Let's get you switched onto the microscope here, and let's do an iPhone 6s backlight rebuild today. I have got these larger coils in stock, but I'm going to be scrounging for the smaller coil. I have heard rumors of people putting jumpers across them. Don't hold me to that. I don't know if you can do that or not. I've never tried it. Okay. Are we ready? We're ready. Okay. Now, do this right the first time. Okay, I ain't going to do this again. Get these coils out of the way because I have confirmed that they are complete and utter garbage. Let's try our new scraper thingy from Union Repair. Can it get all the way down in there? Yes, it can. Yeah, good enough. Can you get between those two? Cool. All right. Let's go ahead and carve out around our backlight driver. Yeah, I'm worried since I had stuff so severely welded to pads that I might actually have stuff here that's severely welded to pads. Let's find out. Okay, let's get the coils out of the way. What a mess. Okay. Ah, look at that mess. Is that discouraging or what? I could imagine how somebody that doesn't do this shit every day would get something like this started and just go, oh, and just totally fucking panic. Now, I could probably... get down in there and just solder right onto that little thing there and leave our driver in place, right? Yeah, I already scraped around the driver. And what's the odds of our driver being messed up anyways? The driver's probably messed up anyways, right, guys? Right? Let's take it off the board, shall we? Alright, looks like I'm missing a significant portion of my blade. We don't want to float the strobe driver here, or this phone will have issues with the flashlight. It's just marvelous. All right, so let's go ahead and clean up these little pads here. And we'll see if we've got some continuity here to deal with. If I have continuity here to deal with, I'll run my jumper to the coil instead of underneath this IC. Big old chunk melted out of this thing. This stuff all got really, really hot, man. So what we're going to do here, we're going to check and see if we've got continuity between these two pins here and this side of the coil right there. So I'm going to put either probe here and then here. We have no continuity. Okay, so my choices here, we need all three of these to connect. We need that. So I think what I'm going to do here, we're going to have a diode here, a big fat capacitor here. So our only way in really is right here. I could take this diode that's supposed to go here and I could flip it around and put it between here and here and then run us a jumper from here over to here. I could do it that way, but then I would have to have a coil here that was smaller because the diode would be here in the way. I think what I'm going to do, I'm going to run a jumper from here. I'm going to have it jag up in here and make a detour here to form us a pad. And then I'm going to have it come around and solder to there. So that's going to be my plan for a backlight jumper. Okay, so we're going to take and solder our jumper wire right there. Tack it down a little bit so that I can get a hold of it with tweezers. Okay. Now, we're going to need this wire to make a turn. We're going to solder it down right there. And now we're going to tin up this little spot here that I'm intending for my diode to sit on. We're actually going to try to put a big fat blob of solder there. Here we go. Okay, so we got a nice big fat blob of solder there for our diode to sit on. So let's trim off our wire down here. And clean this up with alcohol a little bit because we're going to need a little bit of adhesive. I could probably do this without adhesive and just like let nature have control of my life. Oh Lord, did you see what I just did? I think I better use the adhesive. Nature is doing a shitty job of controlling my life. Alright, now, I'm going to stop being so fucking arrogant and be more careful cleaning this up. Okay, so now what I'm going to do to make sure that this stays in place, we probably could just use surface tension, as I've always done in most of my previous videos, but I have started to conform to the idea of conformal coating, no pun intended, and I have been liking what this stuff does for me. It's sort of like concrete in a microscopic world. All right, so that ought to do the trick. Now I'm going to hit this with ultraviolet light for just a few minutes. Okay. We are back with this thing. The mask should be cured up. Let's have a look at that and make sure the mask is cured up. There is our beloved masterpiece. This stuff cures up like concrete, which I am thankful for. Oh yeah, it actually cures really fast under that lamp. I I think normally what I would do is I would put the driver on first and then slap these other components on it. But I think I am halfway tempted to do the other components and then the driver. I'm actually a little bit torn as to which way to do that. So let's just get it done. Let's make this backlight work so that I can move on to my next repair. Hopefully make this. Let's hopefully make this backlight work. All right. So I want to get some leaded solder on this joke of a trace here. Okay. Let's go ahead and get our big boy cap in place. Okay. Let's see. We have got brand spanking new iPhone 6s backlight, 25 volt, 10 micro, farad 0605. They are humongous things. It's like trying to solder a school bus to a logic board. Go. So we are going to be delicately placing this school bus here. It is. It's like after working with 01005 all day, these are like soldering a school bus. Okay. There we go. And I like the way the solder beaded up on the end of my jumper there. It actually looks, that looks really good. All right, so now that we've got our school bus in place, I'm going to go ahead, let's place our first diode. Okay, so here we are, we've got our next diode. It's going to go in there just like that. I can smell the plastic on my new microscope light burning. My other one, I pretty well had it burned off at the right angle so that my hot air didn't touch it. And this one, I'm touching it with the hot air again. Okay. I should have tinned the pad on this diode first. But what are you going to do? I didn't. It would be fine. Okay, we're going to go ahead now. I'm going to grab my next diode. Brand spanking new long strip of diodes that I've used quite a few out of. And it is going to go right there. Luck shot. You see that diode get sucked up onto the end of my flux and then land right where I needed it? I should have played it off like that was on purpose. That would have been rad. All right, let's get this diode in place. Then we'll do our we'll go ahead and do the coils, and I'll do the driver last. We're going to leave it. I don't like how it twisted off to the side, but it's electrically fine. We're going to leave it. That will be fine. My beloved crooked diode. This will be the new microscope lamp and the crooked diode. Will be the title of this video. All right, we're going to drop a coil in here. Is it too fat or is it going to fit? It's going to fit. Of course it's not the right coil. Okay, we're going to call that good. Seems like every time I record a video removing a backlight coil, I have to scratch up the motherboard. That's my signature video thing. Okay, we're going to get a little bit more leaded solder on this coil here. Should be good. Here we go. We got some brand spanking new backlight coils. Grab us one of those. I always point at it with my finger. Otherwise, I will lose track of it. And we're going to sit this right here. I'm really not concerned with my orientation on these coils. I imagine there is some minute thing dealing with, like, probably some inductive effect with nearby components and things like that, but I don't think the polarity of these coils really makes you any significant difference. So these, I just put them on there exactly like they fall. This one I put on there like that just so I would line up the rest of the little white dots. See, got to make sure all those white dots line up. Let's solder our coil in there, and then we're going to drop us a driver on this bad boy. Normally on these, I typically do the driver first, not for any real specific reason. I see a stray piece of solder way up there we got to deal with here in a minute. I normally do the driver first and then do all these components, but on this one I wanted to keep an eye on my jumper wire through the duration of this repair. There we go, we got a nice melt on that one. There we go. So here comes U4020 coming right up. There's one. Oh, I don't remember if these have leaded or lead free on them. I should probably reball it, but I'm just going to go ahead and put it on. So let's take our brand spanking new U4020. We're going to put it right about there, right about where it goes. And let's start lining this thing up for a drop. Boy, there's enough solder here. I should probably remove the balls from U4020. We've got ground on that side of it. Okay, what I'm going to do on this one, I feel like I've got a lot of solder there, okay? So I'm going to take this IC. I'm going to come over here, I'm going to flip it over. I'm going to take those two balls. I looked at the schematic here and I see I've got I2C lines all around these two balls. So I would just simply like to make those balls a little bit smaller. There we go. They've still got solder on them. I have taken some of it away. Okay, so those should both land at our bottom right position, right? There we go. I feel much better about that. I don't want I see that I've got I2C lines nearby, and I don't want to screw up the phone by shorting a higher voltage line to one of these I2C lines and smoking the power IC and the CPU, smoking everything on the I2C line. So let's finish this backlight job. I'm going to go ahead and set this IC on here. Pretty sure we're going to be okay now. Just can't quite get the tweezers in there beside it. And I'm not going to edit this shit out either. I'm going to show you all my struggles. Oop, I got debris here. You can't have debris under it. I would have felt more comfortable if I'd known that I switched this over to leaded solder. Okay. It's definitely lead free. I can see all my leaded is already melted. Let's go up a little hotter because we need lead free to float. Okay. Let us drop this into a housing and see if she'll give me backlight. We've got the supply on, and I'm going to press the power button. Do you think we'll get backlight, or do you think we'll get smoke and fire? I hope we get backlight, because I would like to clean this up and move on. Ah, bummer. No backlight. Wah, wah, wah. But it is booting, right? Alright, so we get no backlight. After all my hard work, no backlight. Alright, so here's screen capture. I made a wire, okay? I made a wire that came out from here. It hooks up to this diode. Out and around and hits this coil. We've replaced this diode. And we have replaced both coils. Now, L4021, the coil that I used, is from a scrap phone, right? So it could be L4021. Let's have a look at this a little closer here. I got both of my diodes on properly. The IC is lined up right. Let's check for continuity across the coils. I'm going to set my multimeter to beep so that hopefully you will be able to hear it. I'm going to put one probe on this side of the diode and the other probe on VCC main. Okay, so what I've done there is I've checked this coil. Now I'm going to check the other coil. Can I just... I can check it right across here, so that coil's testing good. The diode don't move. Let's check ground there. We should get no ground here. So that's proper. Between our filter up here and backlight output here, 0 ohms, that's proper. This suggests that the driver's not working. Well, it was hard shorted too. Maybe we got a bad diode, but I'm going to say that this suggests that the driver's not working. Let's put a different driver on it, okay? Okay. So here we are back under the microscope. We're going to heat the hot air up, put our shield back over the CPU. Damn it, this was supposed to make me look smart. All right, let's get the stupid driver back off of here. I bet you I screwed it up. I bet you I got something bridged under it. I don't have any funny resistances, though, funny loads or anything. Okay. Here we go. Let's clean all this ruckus off of here and put another new IC on it. We won't reuse that one. You know, I might have just gotten a bad IC. Okay. Now, this time around, I'm going to put leaded solder on the IC. I want to make sure that I know what the melting point of this is going to be. Lead-free solder is a fucking joke. It melts too high, it cracks too easy, it looks like grimy, grungy crap. And it should not have been used in devices that are thrown around and used in the real world. It breaks too easy. Let's just use that one. All right. So much for doing that all dainty and pretty. Here we go. We're going to melt it at the bottom right corner and sweep it to the top left. Yes. There we are. Nice, pretty, beautiful, shiny, elegant, symmetrical, non-hairy leaded balls. And we know they will melt easily. All right, we are ready to do this. Here we go. Start warming this up, and hopefully I don't fling the IC, because now it's not just any IC, it's one that I just spent time reballing. So it'll be a good little IC. Stay lined up here. Here we go. Man, that moved way too much. Maybe it was just an optical illusion. Maybe I didn't really do such a bad job putting that on there. That looked like crap. Alright, so let's go ahead and clean it up. We're going to try it anyway. Okie dokie, we're going to go ahead and try this out before I clean this up any farther than that, or put it back together, because now we know it didn't work the first time. Okay, we got the power supply set for 4 volts, and I'm pushing the power button. And we still get no backlight. Ain't that a bitch? Maybe that one diode's not making a connection. Let's pull that diode off of there and look. I needed that diode, fucker. Okay. Today, we're going to fix the backlight on this iPhone 6s. Now, after I've checked these components, and I know we've got continuity out to the connector, then I wind up in a situation where I've got to remove the IC and start checking diode mode measurements against a known good board, and that's usually not necessary. Well, maybe I should have just straightened this diode right here to begin with. Maybe it was that all along. So I'm not going to do any cleaning on this because I'm going to assume that I'm just going to get it dirty again. There we go. It was. It was just a bad solder joint on a diode. I'll be damned. Oh, lordy, lordy, lordy. We're going to let this boot up. I'm going to make sure touch works, and then I'm going to call an end to the video before I go back and actually finish this repair. I'm going to clean the flux off the board. I'm going to go ahead and put some, probably put some UV mask under the 2 diodes. You've seen how the one contact that they had to solder to, their big long pad, it was raised all the way up. So I'm worried that those diodes could have play in them, and these things, they take really hard drops, and if I don't reinforce that, then this thing will wind up coming back for warranty work. So let's see if we got working touch. It's dim, but we do absolutely have backlight. If I can get it to unlock. Alright, it does have a passcode. Let's see, do I have a passcode? Yes, I do. So we've got the phone unlocked. Turn the brightness up here so everybody can see that backlight is in fact working. And this is going to be a successful repair. I am going to go ahead and call a slide to power off here. I'm going to go ahead and call it into this video and get this repair finished up so I can move on to my next job. I am not going to be recording the rest of this repair because this is going to be a long-winded little fucker to edit anyways. So that is going to be it for this video. I do thank you all for watching. I thank you for subscribing. Thanks for clicking like, and thanks for sitting and watching me beat my head against the wall trying to figure out why this phone did not have a backlight. So the moral of the story is, be sure and tin the pads on your diode, folks. If I would have tinned the pads on my diode, this would have been probably a work on the first shot phone. So that's going to be it. I will see you next time. Thanks for watching.